Welcome back. We're talking geometry. This is Mr. Greenstein's geometry course and chapter 7.2, properties of parallelograms. So what is the definition of a parallelogram? And a parallelogram, there's lots of different properties that you can associate with parallelograms, but the definition itself is that it is a quadrilateral, so it's a four-sided figure with two pairs of parallel sides. So once we have this definition, then all kinds of things happen. All kinds of properties about parallelograms happen. And the first one is the opposite sides theorem. So it says that the opposite sides, like this side here and this side over here, are going to be congruent. And the same thing with the top and with the bottom. They're going to be congruent. So that's the opposite sides theorem. Another thing is the opposite angles theorem. So with the opposite angles theorem, we know that like angle D here and angle B are going to be congruent, and likewise A and C. So we have opposite sides and we have opposite angles are congruent. And with these theorems, we can actually do some problems. So here are a couple problems on your notes. Copy down the rest of the information there and work with that and come up with some answers. You can pause and then we'll revisit when we are in class the next day. Continuing on, there's the parallelogram consecutive angles theorem. So consecutive angles are supplementary. So if a quadrilateral is a parallelogram, then consecutive angles are supplementary. And we could say angles like D and C are consecutive, so they're going to be supplementary. Therefore, when you add them together, they add up to 180 degrees. Just like we have here with A and D, so they're going to be this angle and this angle here are supplementary to each other, so they add up to 180 degrees. And that's going to be true no matter which way that you look around the parallelogram. Another theorem is the diagonals theorem, and that says the diagonals of a parallelogram bisect each other. So they bisect each other. So in here we have this and this are congruent segments. And the same thing is this and this. These are congruent segments. Diagonals bisect each other. Here are some exercises that you can copy down, and then when you're you can pause this and work on these, and then we'll revisit these in class the next day. Now let's go on to a proof. Now let's say that we have this situation with two parallelograms, and in addition to that we have some lines. We have the line A to D to E, and we have the line C to D to G. And they're collinear points, so we have two lines that cross. So the first thing we're going to do in this proof is we have to analyze what is the best thing to use to prove that angle B and angle F are congruent. Well, we have a couple things at our disposal. One is that we know that these two lines cross each other, so maybe there's some angles in there that we can use. And we also have a theorem about the opposite angles are congruent. in a parallelogram. So the first thing we're going to state is that the parallelograms, these are two parallelograms, and that's given. And then the next thing that we notice is that the cross of these two lines right at the point D, they're going to be congruent because they're vertical angles. So we can say that CDA and EDG are congruent to each other. Another thing that we can say is that using the fact that opposite angles are congruent in a parallelogram, we can say that angle B here is congruent to its opposite angle, and F is congruent to its opposite angle. So we can say that because of the parallelogram opposite angles theorem, that B is congruent to CDA, and EDG is congruent to F. Well, if you look, we have angle B is congruent to CDA, CDA is congruent to EDG, and then EDG is congruent to F. So let's just cut out the middleman and use the transitive property of congruence and just say that angle B is congruent to angle F. And then that proves out our theorem. Let's move on to the next thing. Let's find the coordinates of the intersection of the diagonals of this parallelogram, LM, N, and O. So L is 1 over and 4 up, so it's right around here. That's L. And then we have M, which is 7 over and 4 up, so it's right around here. And that's M. We have N, which is 6 over, and here, and then O, which is here. So that's O, and this is N. And we connect those together, we get a parallelogram. With that parallelogram, then we have diagonals. So the diagonals go from vertex to vertex like that. To find the midpoint of those, the midpoint is the midpoint formula, which is x1 plus x2 divided by 2, y1 plus y2 divided by 2. And we know from the theorem that says that these two green lines here, the diagonals, they're going to bisect each other. Therefore, we're going to have, this is going to be congruent to that, and this is congruent to that. So we know that the midpoint in each one of those lines is going to give us what is the coordinate of the intersection of the diagonals. We only have to find it for one of them. So if we were to find, we would look for the midpoint of, say, L and N, and just calculate it from that. Let's look at this next problem. We have a parallelogram WXYZ, but we're only given 3 of the points. So the first point is going to be -1, -3, which is around here, and that's W. We have X, which is -3, and 2, which is here, so that's X. And then we have Z, which is 4, and -4, which is right around here. So that's Z. If I connect the parts that are told to be connected, if I use this as my model, I'm going to be connecting W and X. So I connect those two. And Z and W. So Z and W get connected. So there are 2 of my points, or 3 of my points, vertices of the parallelogram. if I want to find out where y is, then y is going to be somewhere around here. And the way that I find it is this. I move from W and I count over 1, 2 spaces, and then up 1, 2, 3, 4, 5 spaces. So over 2 and up 5. So I'll do the same thing with Z. 1, 2, and then 1, 2, 3, 4, 5. So right here at 2, 1, I'm going to have Y. So I'll put a point there at 2, 1, right around in that area, and I'll call that my Y. And if I connect that, then I have my parallelogram. So that's how we find a parallelogram using just 3 points. In class, we'll study some more about the properties of parallelograms. That's all for now.